In my previous lecture, I discussed the relative velocity method of a mechanism. Now today I discuss the example of relative velocity method.
The crank and the connecting rod, the length is 0.5 meter and 2 meter. The angular velocity of crank is 180 rpm, and the inclination of the crank from the bottom dead center is 45 degree, and the crank is rotate clockwise direction. And we have to find out the velocity of the piston, the angular velocity of the connecting rod, and the velocity of point E. This is the model of slider crank mechanism. Now the slider crank mechanism. Here in the numerical, in the example, this is crank OB and 0.5 meter long. The angle is 45 degree. The connecting rod, the crank OB is 0.5 meter. Connecting rod PB equal to 2 meter, and number of rotation of the crank is 180 rpm is given. So you have to find out the velocity of slider P. On our velocity of slider so first draw the configuration diagram. The configuration is given, so first draw the configuration diagram to a scale. Suppose 0.5 meter scale, OB equal to 0.5 meter, that is I consider 3 centimeter scale. In scale 3 centimeter equal to 0.5 meter. Sorry, I consider it as 1 centimeter scale. 0.5 meter equal to 1 centimeter scale. Then that is 1 centimeter, and 2 meter, PB 2 meter means 4 centimeter scale. 0.5 means 1 centimeter scale and 2 meter means 4 centimeter scale. Now draw the configuration diagram. The angle is 45 degree. This is the center line. The angle of the connecting dot from the bottom dead center is 45 degree. And OB means 1 centimeter scale. The crank is rotate. That is 45 degree. Now PB, the connecting rod, is 4 centimeter scale. So 4 centimeter. There is 4 centimeter that is intersect here. So this is 4 centimeter. And there is a slider, there is a piston which is slide on the link. There the point is O, and this point is B, this point is P, and the fixed point D. There are two fixed points O and D. Here the the number of rotation per minute is 180 rpm is given. So we know the angular velocity of the crank, omega equal to 2 pi n by 60, 2 pi into 180 divided by 60, 120. So that is 4 pi. So velocity of B with respect to O fixed point, that is 4 pi into the length 0.5. So velocity of B is known, that is 9.42 meter per second. Now draw the velocity diagram and consider some scale. Consider a scale. Here suppose 9.426 equal to 3 centimeter scale. In scale 3 centimeter means 9.426 meter per second. Point O and D is fixed, so this is the point O and D. This is a single point, and the velocity of point B, which is passing through O, is perpendicular direction of the link OB, of the crank OB, and that is in this direction because the angular velocity is clockwise direction. So velocity of B with respect to O passing through, velocity of B passing through point O in velocity diagram, that is perpendicular to OB. I draw the parallel line of velocity in the direction or perpendicular line of OB. So this is the parallel line of the line or perpendicular line from of the link OB, and here we know that is equal to 3 centimeter. We consider here the VB equal to 3 centimeter. Now the velocity of point P, the diagram is velocity diagram is velocity of P the passing through point B and velocity of P passing through point D. These two lines intersect where this is the point P. So first I draw a perpendicular line of length PB. This perpendicular line is the direction of velocity which is passing through B, in the velocity diagram. So I draw the line from point B in the velocity diagram, parallel line. This is point B. Draw the parallel line of this line, velocity. Now the velocity of point P with respect to D, which is in this direction, in the horizontal direction, because the slider is slide horizontally, and we find the parallel line of horizontal line from point D. So these two lines intersect where, that is the point P. Now if we measure this is first I measure this. PB distance is B of PB .1, and we know 9.426 means 3 centimeter scale, then 2 centimeter scale, 2.1 centimeter scale means what? That is the value is 6.8 meter per second. The velocity value is 6.8 meter per second. And if we measure this distance, also you can find the velocity of P with respect to D or with respect to O. So velocity of P with respect to O equal to, this is 2.85. So that is equal to 9.426 divided by 3 into 2.85, and that is equal to, we get the velocity of the slider. So the velocity of the slider P with respect to B equal to 6.8 meter per second. And there is we have to find out the omega, the angular velocity of connecting dot PB, that is equal to velocity of PB divided by length PB. So here velocity of PB is known to us, that is 6.8 divided by PB, the length is given 2 meter. So 6.8 divided by 2, that is the angular velocity of connecting dot. Now if we have to find the velocity of E with respect to point B, then we know how to determine the velocity, of point E, that is velocity of point E with respect to B divided by velocity of point P with respect to B equal to EB by PB. So here
Okay, thank you. I'll also discuss the another two example of relative velocity method. And if you have any problem, please inform me through the email, and you can comment on the comment box. Thank you. And if you like this video, please like it and subscribe my channel for more videos. Thank you.